Welcome to Study Loop.
So for part A, we'll be using equation 1033, and we can say that the total moment of inertia would be equal to md squared plus m times 2d quantity squared plus m times 3d quantity squared. This is equaling 14 times md squared. Now, we know that the work is simply equal to the change in kinetic energy. This would be equal to 1/2 times the moment of inertia times omega final squared minus 1/2 times the moment of inertia times omega initial squared. Omega initial squared is going to be 0, so this entire term is eliminated. And now we can solve rather. So 1/2 times 14 would be 7 md squared omega final squared. This would be equal to the work done. So we can say that the work done would be equal to 7 times 0.010 kilograms multiplied by d of 0.020 meters, and our final angular velocity of 20 radians per second. Quantity squared, this is giving us work done of 11.2 times 10 to the -3rd joules. This would be our final answer. Now, for part B, we can say that omega final equals 40 radians per second, and omega initial equals 20 radians per second. So now we can use the exact same equation, however, we can't eliminate this term. So we can say that the work is going to be equal to 1/2 times, we can say 7, 1/2 times 14, so 7 md squared omega final squared minus 7 md squared omega initial squared. This will simply be equal to 7 md squared times omega final squared minus omega initial squared, given that the mass and the distance, of course, does not change. So the work would then be equal to 7 times the mass of 0.010 kilograms times 0.020 meters times 40 radians per second quantity squared minus 20 radians per second quantity squared. And we find that the work done is equaling 33.6 times 10 to the -3rd joules. For part C, we have omega final equals 60 radians per second, omega initial equaling 40 radians per second. We can solve again. The work would be equal to 7 times 0.010 kilograms multiplied by 0.020 meters multiplied by 60 radians per second quantity squared minus 40 radians per second quantity squared. Close parentheses, the work done here is going to be 56.0 times 10 to the -3rd joules. For part D, we're going to use equation 1034. And we know that from this equation, the slope essentially should be equal to 1/2 times the moment of inertia, or 7 md squared. So essentially, the slope, we can denote this as m, will be equal to 7 times 0.010 kilograms multiplied by 0.020 meters quantity squared. This is equaling 2.80 times 10 to the -5th, and the units here would be joules seconds squared per radians squared. That is the end of the solution. Thank you for watching.